Okay, so a sports car starting at rest can achieve 30 meters per second in 4.7 seconds, according to the advertisement. The figure below shows data for Vx as a function of time as the sports car starts from rest and travels in a straight line in the positive x direction. What is the average acceleration of the sports car from 0 to 30 meters per second? B, what is the maximum acceleration of the car? And C, if the car has a displacement of 750 meters from time 0 to time 19.1 seconds, what is the car's average velocity during the entire 19.1 seconds time interval? So the first thing that I did was I drew this graph, and these are the meters per second by the time per second, and it shows you exactly what's happening in this data sheet table. So we know this is time, and then we know this is the velocity of meters per second. So the first thing I do is to understand what we need to find. So acceleration average, which is the acceleration average for Vx equals So in question A, we need to find the in question B, it's asking what is the maximum acceleration of the car, so we have to find the average. So part C, we need to find the change. Well, the velocity average in the x from t equals 0 to 19.1 seconds. So back to solving part A, the car starts from rest, so the x initial is going to be 0, which is right here, and it reaches v sub x at 30 meters per second at a time of 4.9 seconds, according to the data table. So using this time interval, we can find that this value by using the equation of a average acceleration in the x direction is equal to the change of v sub x divided by the change of time. I plugged up my variables in for that, and I get that it's 6.1 meters per second squared in the positive x direction. Now B, the acceleration component of ax at an instant of time is the slope of the tangent line to the v sub x times t graph that I have written on the other page of this at the time. So find the maximum acceleration for the steepest part of the graph. So in this case, the largest slope occurs near t equals 0, right when it's starting out. And I drew a tangent line to illustrate this. It passes at t equals 0 and passes through t equals 0, and the values for the rise and the run to calculate the sum of the tangent line. So the tangent line passes through the 2 points t equals 0, comma Vx is equal to 0, and also passes through at 6.0 seconds, and it's going 5.4 meters per second. So, or at 55.4 meters per second. So the rise is going to be 55 meters per second. So the slope of the line is going to be equal to this equation here, which is 55. Well, it's a sub x equals 55 meters per second minus 0 meters per second divided by 6 seconds minus 0 seconds. It's equal to positive 9.2 meters per second squared. So the maximum acceleration, it's 9.2 meters per second squared. So to find part C, we know the displacement, so we just put that over our time interval. So we have P average, which is in the x direction, is equal to tangent x divided by change in t, which is 750 meters divided by 19.1 seconds, which gives you 39 meters per second squared.